Hello, today we want to talk about one application of the AMGM inequality and one corollary of that. Let's start out with the inequality number one, which is the direct application. So mm, as just a short reminder, if we have x1 to the power of 1 times y to the power of p2, that's smaller or equal to p1 times x plus p2 times y if these weights are bigger or equal to 0 and they sum up to 1. I mean, actually, the generalized AMGM inequality it's true for general piece. So if we have n terms, but for our case, we only need 2. So let's adapt this for our case. We set p1 as alpha divided by alpha plus beta, and p2 equals to beta divided by alpha plus beta. Clearly, they are positive because our alphas and betas are positive. Now let's add them together, and then we can see that they sum up to 1. Okay, so we can actually use the generalized AMGM inequality. We want to start with the right-hand side. So alpha divided by alpha plus beta times x to power of alpha plus beta plus beta divided by alpha plus beta times y to the power of alpha plus beta. Now, let's treat these things as our x's and y's. So this is just basically x prime and y prime. This is bigger or equal to x to the power of alpha plus beta to the power of these p's, these weights. This is p1 and this is p2 to the power of alpha divided by alpha plus beta times y to the power of alpha plus beta to the power of beta divided by alpha plus beta. Oops. So basically we just applied the AMGM inequality on x prime and y prime, and yeah, using just a different notation. That's a p1 and that's our p2. Now, what we can see here is that we can cancel this alpha plus beta in here as well, and then we get x to the power of alpha times y to the power of alpha. So we have shown exactly this inequality. We just read it from right to left instead of left to right. I think it was easier to see it if we start out with the right-hand side. Now, let's go to the corollary. Let's actually copy this and start out here. We actually don't need this. And this here. Good. 2005. I think that alpha is 2004. I think it's pretty obvious that we have to do something like this. And then beta is 2000. No, beta is actually just 1. And then we have alpha plus beta equals 2005. Actually, no, we have to do two estimations, one for this and one for that. They are different estimations. So let's start out with those two things individually. Let's start with this and then with the next one. Okay, so this here, we say alpha is 2004 and beta is 2000 is 1. Then alpha plus beta is 2005. And okay, let's just get right to it. X to the power of 2004 times y. This is smaller or equal. We know that how to use the previous one. So we have our alpha, which is 2004, divided by alpha plus beta, which is 2005, times x to the power of alpha plus beta, which is 2005, plus beta 1 divided by alpha plus beta, y to the power of alpha plus beta, which is 2005. Maybe we write it out as just a small reminder. X to the power of alpha, y to the power of beta, smaller or equal alpha divided by alpha plus beta times x to the power of alpha plus beta plus beta divided by alpha plus beta times y to the power of alpha plus beta. And we just use this inequality from number 1. That was our first inequality that we proved, and we just inserted the alphas and betas correctly. Now let's go to the second part. What was that? X and y to the power. or of 2004. Now we use it differently. Now we use alpha. For alpha, we will insert 1, and for beta, we will insert 2004. Of course, for the summation, it stays the same, just 2005. Now let's estimate the second part, x into x y to the power of 2004. So our alpha is now our 1, and our alpha plus beta stays 2005, times x to the power of 2005, because we still have alpha plus beta, plus 2004 divided by 2005, because our beta is now 2004, times y to the power of alpha plus beta, which is 2005. Okay, now we use them together. So x to the power of 2005, y plus x and y 2000. Oh, that's actually a 4, sorry, in 2004. Now we do the estimation for both. What did we have for the first one? We had 2004 divided by 2005, x to the power of 2005, plus 1 divided by 2005, times y to the power of 2005. That was our first part. Now we do our second part, which is no, it was not 2000, it was just a 1. We have a 1 divided by 2005, times x to the power of alpha plus beta, which was 2005, plus 2004 divided by 2005, times y to the power of 2005. Okay, so now we get 2005 divided by 2005, x to the power of 2005, plus 2005 divided by 2005, y to the power of 2005. Of course, these will just cancel, and then we have x to the power of 2005 plus y to the power of 2005. Yeah, and that's it, basically. We have finished our proof.